in any case, we got the first unit connected today and did a speed test, and we got about 400 megabits down and 350 to 400 megabits up, which is one of the better speeds that we see on the mesh. That is thanks to a very short distance link with some latest and greatest Ubiquiti hardware. So they're called Wave APs. They're running on 60 gigahertz, whereas most of our stuff is 5 gigahertz. 60 gigahertz doesn't work very well in the range, so the short distance is important for it to have a good amount of uptime. But yeah, it was exciting.
Which hubs are going back to?
I think it's going straight to SN3.
Straight to SN3.
Which is,
South has a Wave Nano.
yeah.
Or a Wave AD Micro or whatever.
Does anyone not know what SN3 is? Cool. So SN3 is Industry City, Brooklyn. It's I guess there are some furniture stores, right, Dan? Yeah, there are some furniture stores, but there's also a data center just on a couple of the floors of the building. So that's a big place to get connected to the internet, and we get a 40 gigabit internet link donated to us from Pilot Fiber. So we connect to them, and then we have some antennas on the roof and broadcast out from there. So, yeah.
I guess we are less and more live now.
We're more or less live. Okay. More live. Okay. Cool. So yes, again, I'm John. I've been working on this Olmsted Hub for, I guess, I don't know, 4 or 5 months at this point in time, but it's slowing down now, thankfully. This is a 400 unit building on the Upper West Side of Manhattan. It's right off the park. And let's see, what are some fun facts? It's got 400 units, but they're kind of 2 buildings that are just sandwiched together. So there are 2 separate elevator shafts, 2 separate sets of emergency stairwells. So we basically have to treat them as 2 entirely separate buildings with a joined basement. That's what we've been working on. So there's a single basement rack. There is a network rack on the roof that powers all of our antennas. There's a fiber link going between them. And then we have currently in progress, and why the project has stalled for a little bit, is that we're waiting for a dark fiber lease from, again, Pilot, the donors of the 40 gigabit subscription. They are trying to connect us down to a data center so that we'll have a kind of a hardline link all the way back, and we can get internet that way. So, oh, and then the bottom photo is you can kind of see how there are 2 buildings sandwiched together with a firewall in between them. So, yep. In terms of progress, we were able to, I guess I should also probably mention, I've been doing these update presentations for the past few months, so you can go and look at previous presentations on YouTube if you want to see how far we've come so far. But this past month, we had the fiber run in between the basement and the roof, and we got that all buttoned up and in the stairwell and nicely arranged. We also have conduit in place on the outside wall running in between our roof rack and all the antennas up on the roof. So both of those things took a little bit of time. We finished mounting all the antenna masts that we plan on mounting at this site. So the top right photo is of the brackets that the mast is actually going to be clamped down into. And bottom left photo is the progress shot of that actually happening. The photo in the middle is the mast in place with the antennas mounted. And then the photo on the right is, currently working on getting the mast installed. But we have the mast up, the antennas are up, everything is online. We have a connection up to City College. It's network number 7800. That's how this whole building is getting its internet uplink for now until the dark fiber comes online. And then the beauty of the mesh is that it'll actually run in the reverse direction. This will be a better internet link than what City College currently has, so it'll get its internet from here instead. We got our first unit connected as well, which was very exciting. So we have a mix of 1 gigabit and 10 gigabit internet provided in the building with fiber. It's a passive optical network, it's a PON system. That's what you'll see Verizon using in a lot of buildings as well. So a couple of these photos are the splitters in each floor's riser box. So we'll basically run 1 fiber to each floor, and then from that splitter box, we'll split it out to enough ports to serve all of the units on that floor. The bottom right photo is just doing a signal check, so you can actually measure the amount of light that's coming down the fiber and make sure that it's a strong enough signal to get service from. And one of the other things that I was very keen on doing on this site is that we don't want to do any splicing. So we also have a fiber network here at Grand Street, but for every single install, you have to drill a hole through the wall and then splice a connector onto the end of it, and that requires a fusion splicer on top of a ladder, and it's kind of precarious and doesn't always succeed, and the cable isn't very strong. So we're trying to do everything with connectors and couplers and kind of make it a little bit easier for everyone to jump in and actually be able to do an install. This was the big news of the past month, was that Pilot Fiber, who we're renting our dark fiber from, they did their point of entry test, basically saying, we're able to provide internet to you. They weren't actually going to charge us anything until they do this work and make sure that they can reliably provide a fiber connection in between the building and the data center. So they came out at 8 p.m. They were done in 60 minutes. It was incredibly fast, but they were able to take a manhole out on the street and pop some fiber in off this reel on the back of their truck and then get connected. They left the actual termination for a day team that actually just finished up today, as far as I'm aware. But it's progressing along, and I think we'll have our dark fiber very, very soon. And then, yeah, I guess the last thing was we were just kind of buttoning up all of the random things that we did. So we got some lighting in place on our network rack on the roof. We've got cables managed and nicely run all over the place, and then we got labeling done. So that was another whole day or two spent doing this sort of thing. So what's next? Hopefully in the next couple weeks, we're actually going to have our fiber lease online, and we'll begin paying for that. We'll have that 40 gigabit internet linked to all the 400 units in the building. We'll be able to get more people hooked up because they're not going to be sharing a slower link. They'll be sharing the full bandwidth. In July, I'm thinking we'll probably, a side note is that all the fiber we're using, because it's all got connectors on the ends, it all has to be custom ordered, and that takes a month or a month and a half for it to actually arrive. So once we actually make sure that all the trial floor is working okay, we'll go ahead and order everything else, and then in July go ahead and install that. Maybe August, we'll see. And then later, that antenna that I showed earlier at the bottom, the big radar dish looking thing, that is not a very strong antenna for the 2-mile link in between the city college and this particular site. So we're gonna hopefully upgrade it to something a little bit faster. TBD on that. That hasn't really been planned out yet, but yep. Yeah, and then there have been a couple dozen people that have helped me throughout the process. So thank you for everyone. It's been wonderful. Questions?
This was the second time that you used the question.
Oh, yes. Yeah, if you ask a question, I'll either repeat it or take a microphone.
Take the microphone, don't have to repeat something, just take the fucking mic.
You got me, Jolly? Yes. So I believe part of this project is we're pending the 353, the new data center rollout.
325 Hudson is the new data center,
Yeah.
that's correct, yes.
So the dark fiber is going to 325 Hudson, and then we need to get a link from 325 Hudson to 111 8th.
That's, or something along those
or
lines. I think
something
Zach
like
has a
that,
lot
yeah.
of ideas. We had a meeting about this, and there was a conversation to keep both our current data center
Yeah.
link alive at 111 8th Avenue. That's a Google data center down in Chelsea area. Then there's also 325 Hudson, which is the only path that the dark fiber can take.
Yeah.
So that's where we're going to be connecting to for this building. But yeah, we have no.
So we're still pending on that. Is
Still pending
kind
on
of the
that. I
question.
haven't heard a word from Zach about
Got
that.
it.
So
Okay.
hopefully update soon, but we'll see.
Okay.
Because yeah, very shortly we're going to have our dark fiber live, and it needs to go somewhere.
Anyone else?
Yep, we got a question over here.
Just out of curiosity, for the GPON equipment, is that Ubiquiti U fiber? Or?
It's all Ubiquiti stuff. We're using their XGS PON system, which is the 10 gigabit version of the 1 gigabit stuff that we're using here. But we actually can add 1 gigabit modules and 10 gigabit modules into that and support both of them at the same time. So if a Mesh member doesn't need 10 gigabit and actually wants Wi-Fi built into their ONT, we can just install that 1 gig thing into their apartment, and then they're done.
Oh, nice. Are you running the GPON head-in at like a data center, or is that on site in the building?
GPON is on site. We had this issue with Grand where we were trying to put the optical line terminal, the OLT, in a single building and then run it to other buildings, and there were issues with that because then the fiber has to be running at a specific wavelength, and it was getting complicated because you couldn't send plain traffic across that. So we're going to plan on doing the OLT as kind of as close to the apartments as possible, and then just normal internet from then on out.
Interesting. Thank you.
You got another question? Yeah. Oh, yeah, no, here, let's go over here first.
Sorry.
You can wait, Leiden.
This might be like a lowbrow question, but if somebody wants to help you guys, how much do they need to know of like the infrastructure, the
Zero.
hardware?
I have had so many people, their first time doing stuff for Mesh was this, they just kind of showed up and we went through the site and talked about what was going on and then did some stuff, and then the longer that they kept coming, the more stuff they picked up until they kind of have a really good understanding of what's happening. So yeah, there's a lot going on, but if you come, don't worry about it. We'll teach you on the spot. Yeah. Like you wanted to.
Yeah, I think to elaborate on that point, I think we've learned as an organization that having each building have its own, like what Verizon and what they do is they have the OLT in the data center, and it's, distributing out to all the
Neighborhoods at a
to
time.
neighborhoods or whatever. What we've learned is that having an OLT in each building means that that building is its own individual unit, and that, for instance, if for instance, one of the buildings here, we've had issues where they've cut the fiber between the buildings, so we've had to go to a wireless link between the rooftops, stuff like that. So if you have if each building has its own OLT, you could do that. OLT, so that's the distribution, that's the head end basically for the fiber. That's what's sending the fiber, doing the fiber signal. So what we've learned is, basically if each building has its own OLT, it's a bit more expensive because if you've got 3 buildings, you have to buy 3 OLTs, but that means that one of those buildings can operate independently, which is a lot better for flexibility. And so one of the projects I'm working on right now is the fiber build out for that new building on the corner right there, 165 Broome. So we're doing the same thing there where that building is getting its own fiber OLT and whatnot. Like that building will also be its own, it's going to be connected with fiber to the rest of the complex, but it's going to be its own individual unit as well. Anyone else? Yeah.
Is there an updated list of suggested supplies that you need to volunteer?
I don't think you need anything to volunteer. Yeah,
Well, if you
literally
wanna
you could
be-
show up empty-handed and you'd be
Okay,
totally
but
fine.
if you wanted to have your own supplies.
Oh, yeah, if you want, I think
Is there
we
a
have a
list?
wiki where there's a set of recommended materials, but it really depends job to job what you actually end up needing. Many times, volunteers will come with a lead installer to do installs on a rooftop, and the lead installer is gonna have all the materials you need. But if you wanna buy a crimper or, a set of gloves or some pliers or something, that it doesn't hurt. But all that information is on our Mesh wiki.
Okay.
I think we'll end it there. I've got 3 more presentations after this, so awesome. Thanks all.
Who's up next? Just gonna let this here.
All right, how do I sound? Got me? All right, cool. Hi, my name is Dan Miller, High Tech on Slack. My presentation is about a neighborhood update in Bushwick. So Bushwick is a pretty well built out wireless physical place. So this is, you heard from the last presentation, a lot of fiber running to units, fiber going to the building itself from a data center. This is kind of the other half of Mesh, and this is what the early on Mesh was primarily about. This is large buildings. You can see Vernon and Saratoga on the map here that you can see lots of wireless links in those blue lines going between. You can see some light blue ones that are high-speed links. You can see some dark blue ones that are the 5 gigahertz relatively slower links in comparison. And then you can see a bunch of little hubs that form themselves throughout the neighborhood for it. The red dots inside of this map, those are showing individual nodes. So those are rooftop pieces of equipment. And you can see kind of the distribution that's going on in that neighborhood there. So the updates that are mainly going on in this neighborhood, this is going back probably the last, I don't know, couple of years, at least year for sure now. We have some equipment that's called LTU. It's ubiquity equipment, long-term ubiquity. I was going to say unify, but ubiquity. We tested some of that stuff out. We'll get to that in a bit. 60 gigahertz expansion. So as we talked a little bit before in the prior presentation, 60 gigahertz offers a faster link, but it has some issues with rain fade. Some mid-size hub routing. So once you get some data to these hubs, how are we appropriately using that amount of bandwidth that we have from the increased bandwidth from that 60 gigahertz antenna? Some new hubs that have come online, Wilson relatively recently, Thames that's been around for a bit, that's actually my hub, but there's been some improvements over time. And then the general community and just marketing around inside of that neighborhood. So on the right there you can see the LTU antenna, that's an LTU LR, the Wave AP sector, so it's a 60 gigahertz sector in the middle, and then a 60 gigahertz antenna. So a sector is where you have an antenna that feeds out to multiple other antennas. So the one in the middle there, instead of just being an antenna pointed at another antenna, it's an antenna that can feed multiple antennas simultaneously. So the bottom antenna you see there, that's like a client, and then the one in the middle there, you could have a singular one of the one in the middle, and you'd have multiple of the one at the bottom pointed at it simultaneous. So you would typically put that one that's in the middle on a building that has higher bandwidth, and then you would have clients that are grabbing that bandwidth from it from smaller hubs with the one at the bottom. Good question. So some issues that were presented in the Bushwick neighborhood. You can see at the bottom there, overcrowding on large hubs and some 5 gigahertz frequency congestion. So you can see a speed test there, about 1 megabit per second download and about 22 upload. This was the Wilson hub. This was a hub that was serving somewhere around 10 to 12 other buildings. And it was fed from an antenna that placed on another building was getting somewhere around 200 megabits per second worth of speed. So there's a lot of 5 gigahertz congestion going on in that area. It could be from people's home Wi-Fi networks. It could be from other people that are wireless ISPs. It could be from us not doing good frequency planning. There's a variety of things that could cause that problem. So we set out to fix that because that's not good. In the bottom there, you can see the signal of the bottom middle, you can see the signal from the antenna itself. It was showing negative 59 and negative 64 on each side. That's really good numbers. That should mean 200, 250 megabits per second. But in real life, you can see the speed test, consistently was getting about 1 megabit download. And the poor people that were sharing that were probably not very happy. You can see on Vernon, on that top bubble, all those lines going into it. So we have sector antennas again. This is now in the 5 gigahertz spectrum, not the Wave AP on that prior slide, but this is a light AP or horns that you'll see later. And those have about 120 degree fan angles or 90 degree fan angles from them. So you put like somewhere between 3 of them if they're 120 degrees or 4 of them if they're 90 degrees, and you can do a full 360 around the building and people can connect to it. They can have somewhere between 25 and 30 clients attached to them simultaneously before they start slowing down. So we're getting to the point where these buildings, these major hubs that we have in the Bushwick and Brooklyn area, Vernon and Saratoga, there's overcrowding. There's just too many people in the sectors and they're starting to suffer performance from it, performance issues from it. So those are 2 main issues really going on there. So to attempt to look at those, we decided to step away from the LBE or Wave APs not Wave APs, what is it? Light beam, what's AirMax protocol? So AirMax protocol it's not Wi-Fi, it's a ubiquity specific protocol, but it uses the same frequencies and it's how the data looks like over the airwave. And so only things that are missed it again. Air Max. Only the Air Max things can see Air Max things. So similarly, their upgrade path from that, LTU, this is what Ubiquiti has created as a newer, better product. And so we were graciously donated somewhere around 30 or 40 of these LTU LR antennas, and they were sitting in our stockroom, and we decided to put them to use. So we put a sector on Vernon, and you can see the fan angle there in the bottom left of what that looks like. So you know, we were able to hit a couple of our medium-sized hubs. So we got Soft Surplus Hex House, Thames, Jefferson, Wilson, and a few others inside of there. And so we put the one sector, and you can see those horns kind of on the right image there of what the sector on top of Vernon looks like. And that serviced multiple LTU LR antennas, that top middle antenna. They were on the client sites for it. And you can see the speeds that we were getting on that speed test in the top, and that was significantly better. So this is around 47 megabits download and 22 upload. Still nothing amazing, nothing close to what we want, but in that congested area, we were able to get relatively better performance from it. That said, it was not amazing performance, and it wasn't necessarily worth the effort of swapping things out to use that. It wasn't consistent. Some of the sites, Jefferson and Soft Surplus Hex House, those ones, they did pretty well. When you got over towards Wilson, it was poor again. Mainly that 5 gigahertz congestion issue. Whether we use LTU or whether we use Air Max, it didn't really matter. You're in 5 gigahertz and it's suffering problems. So you know, we need to look at something else. That said, we did see decent PTP performance, so point to point. So if you took that LTU LR antenna on the top middle and you put it on one end, and you took the LTU LR antenna and you put it on the other end, instead of one device servicing many, if you just did one-to-one, and then we opened up the channel width from something like 20 megahertz, where the amount of bandwidth you have, all the way up to 100, and took up a big pipe of data, we were able to consistently get good 5 gigahertz performance from that. So a little more on that later, on something that unlocked a very helpful thing for us that we've needed for a while. But there is some good use for this. So we found that even though these antennas don't work very well in the 5 gigahertz congested regions where we're trying to solve these problems, they do have their use case for point-to-points where we can use those 30 or 40 donated antennas in a good way. A lot of help from another volunteer, Matt, on this. He was kind of pushing this effort, and I was helping him out best I could because I'm in the neighborhood. So then moving on from there, we decided we need to get out of the 5 gigahertz frequency spectrum, and the next place to move to after that is 60. 60 gigahertz, you have antennas that are relatively inexpensive for the amount of bandwidth you can get out of them, but as mentioned before, they suffer issues like rain fade. So we're trying to solve the issues here, this 5 gigahertz congestion, the low performance we're getting because those neighborhoods where there's lots of 5 gigahertz congestion, getting more bandwidth to these medium-sized hubs. So if we're only servicing off of the large hubs, if we're using the same technology that we use to get to people's individual rooftops, if we're serving a medium-sized hub with that then distributes that out to others, that's a bottleneck, right? And so we want to be able to get more bandwidth to them, not equal bandwidth to what everyone else has. And that way we don't have bottlenecks in our network. So medium hub bandwidth, 60 gigahertz, offers significantly more performance. 5 gigahertz gives you maybe 200 megabits per second. 60 gigahertz gives you about a gigabit symmetrical. So significantly more, 5 times-ish more bandwidth you have. And also there were some problems that we saw in that area with long WDS paths. So WDS, wireless distribution system, this is where a device that we have, it's a rooftop router called an OmniTick. And if that's on someone's house, and if it's on someone else's house that's relatively close, if your antenna, so like that LTU antenna or LBE antenna or 60 gigahertz antenna that's pointed at something, if that gets dislodged or breaks or something happens to it, those can talk to each other, the routers, and it offers a nice backup path. So your internet doesn't just go out, it just gets a little bit slower temporarily, and then we can help figure out what to do from there. So there were some long WDS paths where no one had direct antenna sites to get and point up at our major hubs. So someone would chain through someone else, they would go through someone else, that would go through someone else, and eventually they would get to poor Wilson that has 1 megabit worth of bandwidth, and then the story goes on. So we wanted to solve that too. We wanted to get a little bit more bandwidth to them so that they could share more. So we decided to test pilot this. There's a tool that Ubiquiti has that allows us to draw out what this looks like. And so you can see the plot of it here. We decided, so this wave AP 60 gigahertz sector, we have a limited amount of azimuth, or the amount of horizontal space that it has that it can service. So we picked Jefferson, Cypress, and Wilson. Wilson being the most needed because of that poor performance. But Jefferson also has a lot of clients, and Cypress relatively recently has a lot more clients too. So we put antennas on there, and also a different one on Thames so that I could do a little bit of testing myself. And you can see kind of at the bottom here, not so well, but 1.6 gigabits per second of retained speed from it. So really, really, really good speeds, a whole lot better than like the 200 or so that it's mentioned on the 5 gigahertz antennas. So once that bandwidth gets to the rooftop, you need to be able to give it to things, right? It's just on the antenna now, so it needs to get distributed to other devices, the people in the homes, the other antennas that distribute it out to all the other people on the medium-sized hubs. So the OmniTick, which is that WDS-style antenna router that I was talking about earlier that talks to each other, that's the tall thing that you see here on the left. And so that does a lot of things for us. It's kind of a backbone piece of equipment. Usually when someone does a rooftop install, they get an OmniTick, and then they get an antenna to point at something, and that antenna is dependent on what you're pointed at. It's a rooftop router, and so it can service multiple clients. So there could be a cable that leaves from there that goes to the first floor into someone's unit. It could go down and go to the third floor. It could go and kind of drape to the building next door potentially. It's not just a one-to-one thing. And then it can also talk wirelessly to others. It only routes about 250 megabits per second, so that's a limitation. And when you've upgraded at these medium-sized hubs from a 5 gigahertz based antenna up to a 60 gigahertz antenna, now you get a gigabit worth of speed to your rooftop on the antenna, but it's not able to go anywhere else. This router can only route 250. So I found a device that is called a WAP, that's the smaller rectangle at the bottom, and that has a newer processor in it. It does a very similar thing to what the Omni does. It costs about $60, and you can attach it to the Omni, and it routes 3 times what that can do. So it ends up being about 750 megabits per second. I tested this out. Very hard to read if you're looking at it on here, but in the bottom right corner, you can see 750, 750. And that's real life numbers that are coming in. That's my personal router at home that's going straight into my unit. So that's coming off of Vernon through a 60 gigahertz antenna, receiving on a 60 gigahertz antenna on the rooftop of Thames, and then going down into my unit, into my home router. And luckily, since all of this piece of equipment is also made by MikroTik, the same company that makes the Omni, our config generators that we have online that help program these, it's also able to configure this device. So it needs a little bit of hacky kludging right now to shut down some of the interfaces because it only has 2 Ethernet ports, not 5. So you have to go through and delete some of those things. But I was able to start from the config gen we have online, enter in a node number, and then just delete the extra interfaces off from it and the beep codes because there's no speaker on it, and it programmed totally fine. If you don't delete them, it will brick the unit, and you need to fix it yourself. So this is kind of cool. And then I realized recently that our SXT, which is that square antenna that's right above it, that has the exact same processor in it. So that SXT, which we normally use to just point at other OmniTicks. So if you are on a rooftop and you can't see the large hub to point your other dish at, if you have a neighbor and they're slightly too far away for your WDSs, for the 2 routers to talk to each other, you can point that little SXT at them and basically harvest internet for your neighbor. That could also be used as a router itself too. And so any of these devices, whether it's an SXT or this WAP, both of those could get added to basically take an individual rooftop and upgrade it once you add a 60 gigahertz antenna to get 750 megabits worth of routing capacity. All for about $50 or $60 of add-on, which is good because those antennas cost about $300, $400. So it's well worth the money to be able to distribute that bandwidth. And it's basically a MIPS processor versus an ARM processor that enables that. Another cool thing about that little WAP is it also can do WDS now. So people that don't want to put an OmniTick on their rooftop, if they have a smaller profile, if their landlord doesn't want to see this big thing, if you want to put it outside of your window on a stick or something that maybe you can't fit all that, you could then put this small little WAP outside your window and it would crosstalk to all of the other ones nearby, and it would operate very similar to how our WDS works on our OmniTicks right now. So that was kind of a cool find. Getting into that specific Wilson hub a little bit more. So like I talked about before, you can see in the top left that horrible chain that was going from this poor guy in the top left through his neighbor, through their neighbor, and then through what was Wilson. And Wilson had that 1 megabit worth of bandwidth, and then there were some other nearby people. And that whole chain, if any one person breaks down in that link, everyone would go out. So we want to fix that. So you can see some of the trials here. On that stick in the center middle is the LTU-LR antenna, which we tested, found that it had about double the performance of the light beam, which is our typically installed antenna, which is the top right antenna there. But double wasn't really enough. We were being able to carry the amount of capacity that this hub had. So in the bottom, you can see, bottom right, you can see the 60 gigahertz antenna that we ended up with here. And then we took down the LTU-LR antenna. That said, we kept both of those on the right because 60 gigahertz, it's a far enough link on this that it suffers rain fade. So if it's very heavy rain, that link will drop and then it will fall back down to the 5 gigahertz antenna to keep it alive. But it obviously suffers the same bandwidth problems as before. And you can kind of see the M train in a red line that's going up and down there. And there's a weird pattern that happens in that part of Bushwick where the Myrtle M train that passes overhead, it blocks people's rooftops from being able to point antennas across the way where we're going. So when the train goes by, it knocks everyone's internet out every single time. And so that you can see kind of in the pictures there's a lot of crisscrossing and zigzagging that goes back and forth, but it never really goes down below that line unless you're kind of further away and you can kind of get a little bit more sight angle above. So we've got some interesting problems we're trying to solve there. And Wilson was a member. We asked them, can we promote you and give you really nice equipment, put on your rooftop, and it will help all your neighbors? And they graciously said yes and dealt with us going on their rooftop 4, 5, 6 times, trying different things out. And now they will be able to have 750 megabit speeds as a benefit from that. So it's nice to share with your neighbors. This has got some of the data from that. Maybe a little hard in the audience here to see, but real speed tests. This is coming from our wonderful support bot in Slack. We were getting 4 megabits TCP download and 5 upload. That was from the antenna in the top right there, which is our normal antenna. Very congested, not what we normally get from that. Then when we moved to the LTU-LR, we got about 40 megabits download, 70 upload. Significantly better, but not good enough that we really wanted to carry the whole hub on it. And then at the bottom, you can see the 60 gigahertz, and it's suffering the routing capacity issues. You can see the CPU usage is 100% on all of the bandwidth tests there, but it's only getting about 200 megabits, 220 download, 200 upload. So that's where that WAP or that SXT as the router would be able to unlock that, move that up to 600 or 700. And you can see on the right side the antenna speeds that were reported, which are false. And it says 22 megabits download when you really got 4. It says 61 when you really were getting 20, or 5. And then 47 when you were getting 40, and 135 when you were getting 70. So don't trust the antenna speeds, trust the real bandwidth from it. So big performance increase as we worked through different technologies and found a good home. So the rooftop, another medium-sized hub. So this is my rooftop. Thames, a lot of equipment. I had a work thing. I bought some stuff. They didn't want it. I put it on my rooftop. That's kind of started this big pole that's here on the left. The idea behind it was a 5 gigahertz cross connect. So it's in the middle of a lot of these other hubs. So you can see Vernon, big hub, Saratoga, big hub. Thames, they're kind of in the middle of Soft Surplus Hex House, Jefferson, Cypress, and Wilson. And so what I'm doing there is I'm pointing 5 gigahertz antennas at each one of them. So it's instead of having a long transmission that crosses all the way over the neighborhood, I can point to point and I can be a router in between all of them. So I'm the last ditch resort that if everything goes out, everything will route through me. And it's happened a few times before. There's also the benefit that I feed from everybody. So I have like 5-way redundant internet on my rooftop right now. And basically all of Brooklyn would have to go out for me to be able to lose that. It's also a really nice test bed. I can just crawl up on my rooftop and put anything we want up there and point at Vernon, which is a very fast and mature large hub. So it's easy to be able to test out new technologies. And you can see there's also this pointy long antenna that's called LoRa, and that's a low speed, not really Wi-Fi. This is for like measuring little raccoons and cats where they are, or flood sensors, or very small blippy things that run off batteries for 2 years. And so we're doing a partnership with NYU Tandon to be able to help them out with some flood watch sensors. So there's an antenna that's on top of Vernon, and it wasn't working so well because Vernon's so high. It's like a 40-story tall building. So we put it on the top of my place, and it unlocked that whole Bushwick area to be able to get their sensors to work. So it's a really nice test bed, and it's the last-ditch effort connectivity spot. Going back over to those LTU LRs, rain fade in the neighborhood. So Vernon, everyone around that part of Brooklyn uses it, and when it goes down, a lot of things go down. So when the 24 gigahertz and 60 gigahertz antennas, when it's really raining hard and those go out, Vernon would just shut off for a little while. And so part of the benefit of the LTU LR testing we did, we found that 100 megahertz point-to-point of pointing just one LTU LR to another, we point that at an edge node that has a VPN that goes back into our data center, and it actually carries the bandwidth of all of Vernon for it. And so the rain that happened a couple of days ago, these are real plots showing the bandwidth jumping off of the antennas that normally are used, and that the LTU LR was carrying that. So that's cool. We now have not solved the rain fade issue, but we have definitely band-aided and patched the rain fade issue for it. So this is proven functionality. It keeps the hub online. It's very happy. And you can see the one part of the antenna there in the top, that's on top of Vernon. And then you can see the other part of it there. And this is on Soft Surplus Hex House, which is a creative space that's in East Williamsburg. And you can see a whole bunch of antennas that we have on there. Over to Saratoga, we also have that other antenna, and that carries Saratoga when that goes out. That's also in the 5 gigahertz area. So reliability too, beyond rain fade, frequency congestion. So that's a huge problem that we have in the 5 gigahertz area. I started charting out all the frequencies. So the FCC gives a certain amount out for people to play with. We are working within that with what constraints we have. And you can see horizontally, although that little bar chart or nat chart, that there's a lot of things on the same horizontal plane with the red lines into each other, and those are interfering with each other, right? So the sector antennas that feed out on top of buildings and fan out, if you have one here and you have one on the other side of town facing back at it, they're on the same frequencies, they'll interact with each other, right? You'll suffer performance from it. So it's a balancing act of manually picking frequencies and adjusting them. We use these things called DFS channels that are where aviation radar operates inside of. And for us to use them, we have to drop off of those channels the moment that we sense that the radar is being used. But that means that all those channels fall on random channels, and it means they're not good. And so we have to manually massage them back after every DFS event. So we have this wonderful Google Docs Excel, and we go into it, and we make sure that we're fixing it for now. This is a great thing for some other database projects, maybe improve. But you can see there's a lot of antennas, and they're all pointed at each other. And this is every one of our hubs with sectors on them, all interacting with each other in a small area. So it's important to make sure that we're manually adjusting those, or else it's going to defeat the purpose of what we're trying to do here. So in community, Bushwick, there's a lot of community events going on right now. So BAM, Bushwick Automata, there's neighborhood installs with Mil Mundos, which is a bookstore and meeting place. We did a whole bunch of community installs. I'll get to that in a second here. But they're a good partnership that we've worked with in the past for getting nodes on top of people's places in Bushwick. Collective Focus is another place like that. They're a resource hub that's in the area. They have a node on the top of their rooftop. Recently, a building was built that obstructed their view to the mesh, and I last week went to the rooftop and fixed it for them. But they provide internet to people in the area, and they're another great place to tap so that people in the neighborhood that don't have internet can learn about mesh and can learn about how we can hook them up. Bushwick City Farm, you can see in the top left and then just below it, that is a place that has a lot of migrants that come and stop by and use our connections there. And we have a lot of statistics that show that that's very heavily used. And Jefferson Migrant Shelter, one of our hubs, we pointed an AP down at the migrant shelter at the base of it, and we can see a lot of people that are inside of that migrant shelter are now getting public Wi-Fi from us and using it. So community helpbacks that we're doing in the Bushwick area, there's a lot of them. that BAM install. So shout out to Willard here, who was the one who set that kind of up. You can see him hiding in a hole and also working on his not Windows laptop in the cold. And then in the bottom left here, you can see another group of volunteers that's putting some things together. So this is one day. We had 12 volunteers from Mesh. We all showed up. We broke apart into 4 teams. And we installed 10 nodes inside that day. And so we still have 11 nodes left to complete inside of that. We got to about half of them. And so there's the next wave coming soon. But you can see on the map, the top left is what we did install. And the bottom right is what BAM or Bushwick Automata was working with us to try and get installed for it. So this is a great community engagement event. If you're looking for a way to volunteer and you're looking for a way to see how to set up these rooftop wireless setups, very different than what John was doing with the fiber inside of a large building, this is probably the next best event to go to, and hopefully we do it sometime soon. This was like about a month ago. So that's a good one. The community statistics from these places, so you can see the Jefferson Shelter, City Farm. City Farm has 3 access points, all very heavily used. You've got like 30 or so simultaneous users per access point, and then on the Jefferson Shelter, you've got about 15 or so. So a lot of bandwidth used, usually 50 gigabytes per day per access point is what we're going through there. And power improvements, we could probably help out City Farm. Their power seems to go offline every couple of days. Marketing nodes, so the idea to passively teach people about Mesh and get them involved. Roberta's Pizza, Farm to People in the Maria Hernandez Park. Roberta's and Farm to People allowed for persistent advertisement to be placed inside of their place to give them free public open Wi-Fi networks in their open space. And so if you're looking at Roberta's Pizza, there's a huge outdoor space. They throw events there. People come see it. There's also a cell phone dead zone side of there. So everyone's internet goes out. They want to go on Instagram. They click on it. They click Mesh. They see what Mesh is, and then they learn about it, right? So there's an install at Roberta's. And then there's also another one that's at Farm to People. Farm to People is fresh produce boxes. It's a big warehouse for direct delivery from like upstate New York, lots of farms. Bring it in and then deliver it out into the neighborhoods. But they also have a large outdoor space and a kitchen inside of it that they hold events at. So those both get heavy foot traffic and a lot of people connecting to their access points. And one of the BAM installs that we did, we were able to put access points on their rooftop as a community benefit and beam it into the middle of Maria Hernandez Park. And now Maria Hernandez Park, that center circle gets about 75 megabits download, 75 megabits upload for anyone that's sitting in the park. And so you can see quite a few people are utilizing that on a day-to-day basis for the metrics that we've got of just connected users for it. Not as much as any of those migrant shelters, but great for marketing, great for getting just the SSID tells people this is Mesh, what's Mesh, and then the idea to passively get people involved in the neighborhood. And at that, went through a lot of time. Any questions? Peter?
Let me switch to my phone.
Yeah, no.
First of all, great job on researching the travelers. I actually been following here.
You're not on yet. Hey, it's on.
Okay, go ahead.
Try again.
Test 1, 2, 3.
Gotcha.
So first of all, great job on researching these routers. I was following your research. Now I've got a couple of questions regarding this. How would you set this up if you want to, if you would like to? Because I've seen a couple of use cases, and I was wondering, would you replace the Omni entirely with that small router, or would you add that to the Omni, like an additional device, and make this as a router and Omni as just the WDS?
Yep, that's a great question, thank you. So I would just add it as a client off of it. So one of the benefits of that OmniTech is that it has 5 Ethernet ports off of it. A lot of times they're not all being used. One brings power in, the other 4 can give power out. So you could just attach this outdoor next to it as a client and it can share power. It uses a maximum of 10 watts, probably won't use all of that unless it's heavily routing. It also has 2.4 and 5 gigahertz antennas, so if you disable those, it could even drop it more. So what I would do is I would keep the Omni so that it's got 6 dB higher antennas on it, so it would radiate and WDS mesh better. So I wouldn't want to reduce the capacity of that, but I would shut the routing off inside of it and make it effectively just a managed switch and use switch level routing on the Omni and then push all of the routing directly over to the access point or the SXT. So I would add it as a client, but then you would edit what you had existing, and that way you can always fall back to the other side if you want to.
I've got one more question regarding this setup right here. You did some research on the hardware, and you're the expert here, so correct me if I'm wrong here. The only difference that I see is the amount of the cores. There is only one core on the Omni, and there are 4 cores on SXT and this new router that you found. Is that correct?
No, so there's a big difference. So I agree with you, yes. So it goes from 1 core to 4 cores, but beyond also going from 1 core to 4 cores, it goes from a MIPS architecture to an ARM 32-bit architecture, and ARM is far more superior of a processor than a MIPS is. So I think part of the benefit is that it's multi-core, but also I think the big benefit is that it's ARM instead of MIPS.
And I'm not sure if you will be able to answer this question, but also regarding hardware. So there is a lot of situations that we are using net power switches. I'm not sure what kind of hardware they're running, but they're running also router OS 6. They can route. Would that be a good alternative to route through those power switches, net power switches versus the Omni?
So I've looked at that too. I do like some of the net powers, specifically the Light 7R is what I was looking at, because you can feed multiple sources of power from multiple different apartments or buildings into it, and then it has one output, but the one output is constrained by the amount of current that comes out of it, and so that's not as beneficial at routing things like having multiple antennas daisy-chained off of it. So I can see where you may add that over time if you have more and more clients in the building, but I wouldn't replace the Omni with the net power for it. But I did look at that inside of it, that I have those all sitting on a table in a row next to me,
I bet you did.
and I tried that all out.
Appreciate it, thank you.
Thank you.
It's a bit of a mystery to me why we have so much 5 gigahertz congestion in Brooklyn, but we don't have it in Manhattan. Does anyone have an idea for that?
I don't necessarily know. The worst pocket by far is in that Wilson area, and you can see that all those red dots in a row. You might think, is it just that many red dots in the same place are bad? But those are all on 5180, right? They're all on the WDS frequency, so this shouldn't matter against what we're doing for AirMax protocol. I really have no idea why it's that bad in Brooklyn in that spot specifically. We don't see that problem in many of the other areas on here, but definitely, I mean, so Vernon and Saratoga, we have lots of overlapping sectors where instead of having like 90 degrees, 90 degrees, 90 degrees, 90 degrees, or 120, 120, 120, and covering just the 360, we double overlap many of them because we've realized that we have too many clients that are pointed at it, each one of the sectors, so they start to lower in performance. Then we add another sector, and those aren't perfectly isolated from each other. And it also could be that we're not the only equipment in town. There's other people on these buildings and in these areas. And so we're easily watching the frequencies that Mesh puts out, and we're adjusting those, but we have no idea what any other wireless ISP or just people in their homes are using.
Yeah, SN1 has an incredible number of antennas on it, and so you would think it'd be worse in Manhattan. But,
You would think so.
yeah.
Yeah, the one megabit was really bad, and we tried moving all the frequencies around to try and get it first, because that didn't mean changing anything in hardware, right? We didn't have to mechanically do anything. We could just adjust frequencies around the neighborhood, and that really didn't solve anything.
Just a quick back to the hardware for a second. So theoretically, if you're doing an install with an Omni and an SXT, would it just in general make sense to be using the SXT as the router and turning off router functionality on the Omni, do you think?
So it would really mean the only time you're really going to need more routing is if you have an antenna that's capable of getting that much bandwidth.
Right, okay.
And none of our 5 gigahertz antennas or the Omni through WDS itself come even close to that. So really it only comes to when you would add a 60 gigahertz antenna.
Okay, cool.
So this building that John and I were at today, it's node number 552. That one it's got a Wave Nano to SN3, and I believe that Wave Nano reports that it should be able to do half a gigabit, like 600 megabit. Laptop testing maxes out at about 300, so I think we are being throttled by the Omni's routing.
Yep.
My understanding from what you've said is that the Omni can switch fast enough, it just can't route fast enough.
Yep.
So the solution to that, I'm wondering if the solution to that would be dropping one of these other routers. The other option I'm thinking is like, I don't know if the HAP or like one of the Indo options is any better as well, and you could do like so like this building, the Omni and the Wave antennas are on the roof. There's 2 antennas on the roof. There's one cable that runs down to the basement, and basically all the other switching for the building is in the basement. So it kind of makes sense that like if I'm going to do a router on a stick, like if I'm going to have a router somewhere else, I might as well just drop it in the basement, where it's more easily accessible and whatnot, and I can just use an indoor one. So I don't know if you've looked at the
Yep.
HAP at all.
So I did. So one of
Yeah.
the members, Josh, that's how he does his, and that's how he suggested that I look at it. I like the idea of it being outdoors because a mid-size hub, which is what I'm promoting this for when you add a 60 gigahertz antenna as an add-on to promote a hub up, that's something that is we want to make that a fixture of the neighborhood. We don't want that just to be based on whoever the one member is that's supporting it in that building.
Yeah.
So I'd prefer all the equipment be outdoors so it's easily serviceable by mesh. So if we need to change or touch something, also if there's multiple people feeding that install, so maybe you have like people on the first floor, third floor, fifth floor, whatever, that means that when one member moves out of the place or around, you don't have to physically go and move that from someone's apartment to someone else's apartment.
This is, for this specific building, this is like all the switches are in the basement.
Yeah, if you have common space, where is that?
Yeah, so it's like, do I throw a WAP up on the roof that could also be an antenna, but I'd probably just use I'm going to be doing SXT links to the buildings nearby.
Yeah.
So I might as well just use the Omni.
Or if you have SXT links, you might as well just use the SXT.
Okay, yeah.
Because it's already there and you already have it.
Yeah.
But that said, it's a trade-off between vandalism, theft, things are on the rooftop, there's something that should be touched.
Okay. Yeah.
So any of those options will work. We have people on the mesh that are doing this right now, and they have an indoor one because it's theirs and it's in their house, and they're a mesh member that's volunteering on a consistent basis. So we know that it's highly accessible. In these instances, it would be really nice just to have them outside because then it's not pertained to one person specifically.
Yeah. I think my main technical question is like, you could put that WAP somewhere else where it has one wire to the, like the Omni isn't going to be, that WAP can be a router on a stick, and it's not going to be limited by the switching capability of the Omni.
Yeah, the benefit of it is you could run WDS on the Omni on one side of a building, and you could have the WAP on the other side of the building, and then people could wirelessly connect through this one, and people could wirelessly, and you could get 2 line of sights totally separate from it.
Yeah, okay, cool. Anyone else?
How does the cost on the WAP compare to the Omni?
WAP's $65 and Omni is $150. SXT I think is like $50. So $50 or $60 for 3 times the routing. And that's really the cost benefit is when you're gonna get a 60 gigahertz antenna, at least the ones that mid-size hubs are gonna have that go long distances, like your GBE-LR or your AF60LRs, those are $300 or $400 antennas. So adding like a $30 or a $65 router to be able to unlock the speed of it just makes sense, right? Cool. All right, well, thank you.
It is. I'm gonna just plug in my laptop real quick.
That's good. Putting it on the table, it reverberates, it's not good.
Okay, this is going to be a little tricky to demo, so I might not do that. But here we go. All set? Okay. So hello, everyone. I'm James, and today I'm going to talk a little bit about DNS. So what is DNS? Just to level set everyone, it's domain name system, the domain name system, and it's what turns a human-readable domain, like the one for the wiki, into an IP address. And it's something that we perhaps use every day, but probably don't think about every day. But I've learned that it's sometimes good to think about these things. So let's give an example of doing a recursive resolution on wiki.mesh.nycmesh.net. So first off, the person with a web browser reaches out to a recursive resolver, and the resolver will try to work from right to left on the domain name. So it'll first try to figure out where is .net. It'll ask that to the root name servers, which don't actually know anything about the wiki. So it doesn't know anything about the far left, but it knows a lot about where .net is. And it takes that back, and it decides to talk to one of the multiple GTLD servers for .net. And it'll ask, hey, where is wiki, and so on. And that will point it to name.com, their DNS service for that section of the domain. And then again, it'll reach out to SN1, which hosts the mesh.nycmesh.net domain. And then it'll reach out one more time to SN1 to figure out that wiki.mesh.nycmesh.net is in fact 18.213.129.204. So I suppose that's, that all happens a lot faster than I can explain it. But it's something that happens a large number of times every single day. And one of the other key takeaways here is that the first, the top two of those things, those are totally not mesh things. They're just internet in general things. But number 3 and number 4, number 3 is with a registrar that NYC Mesh pays money to. And number 4 is 100% mesh. That's a server that is, I think it's a VM that's close to, if not, realistically it's in the SN1 realm, let's say. But yeah, so that's DNS resolution for the wiki. So as I was kind of trying to say, there's multiple levels to this. NYC Mesh.net. I had to do some digging around and searching around to figure out how and where that's actually managed. Basically what I think I figured out is that it's hosted and managed in the user interface of name.com. I actually registered a cheapo domain to see what that looked like and all, and I'll show you guys later. But then there's also the level down from that, which is the bottom of the last slide, and that's managed in this Git repository, which is called NYC Mesh-DNS. And just to be super clear, that's not something I created. It's been there for a lot longer than I've even been living in the state. I just think that it's really awesome. And naturally, if I think something is really great, I think that, we should maybe have more of it. And maybe we should do more things like this. So, like the reasons that I think it's great are that it's really transparent. So like every single person here and every single person on the internet, if they so choose, they can go check out what like the zone file is for mesh.nycmesh.net. I think that's good. And I think that fits really well for like my understanding of this organization as well. And I think there are some other things, like some other good benefits that come with like this existing thing being in Git. And that's like also like people can submit changes if they so choose. So like if you need another DNS entry for some reason, you can just make a request to have one added. You can submit your change. It's like the whole open source thing. I think that's great. There are also like built-in approvals, so that like, I think there was a thing a while ago where like someone tried to make a bunch of changes and it didn't go anywhere. So like changes can be approved, but they can also be rejected, which at times needs to happen. And ultimately, we have a really good like record of who changed what when, which tends to be useful, as I think, especially in super flat organizations. Yeah. Also, like we're in the 2020s, and like nobody has to, with the way it's set up right now, nobody has to like go SSH into some server and like change the zone file and then restart the daemon. Like, no. It just happens automatically because like we probably wouldn't want something that would require like a bunch of like manual effort to go roll out updates and so on. So those are the two big reasons that like I think that this NYC Mesh DNS repository and solution process, whatever you really want to call it, that's why I think it's great. And also a shout out to Zach. If I'm reading the Git history of like who changed what when correctly, I think that Zach started this like 6 years ago. So shout out to him. Yeah. So, as I was maybe alluding to before, great things. I want more of great things. When I was looking into like how DNS worked, I kind of found that you need to look into it. Like there isn't like a ton of transparency. So like I wanted to find a way to manage the name.com DNS like in the same kind of repository. And so the way that I found to do that is using the name.com Terraform provider. That's some open source software that's written, I think, by this guy from the country of Georgia, who made this available to all of us to use, which I think is great. And that I will go on to show that this could allow us to store all of the existing and future configuration for like all of DNS, not just a section of the DNS, in the same Git repository and like automatically deploy it and like have all of these benefits that I was kind of describing. Oh yeah, and like changes via pull requests, yeah. So, just to kind of show you visually what this looks like. Also, I was gonna like live demo this, but like I don't think I'm gonna be able to do that right now. So hopefully look closely here. So like currently, name.com DNS management is on the, sorry, you can't even see that, on the left here. If you want to add a new record, you do so, and you hopefully get it right, I guess, I don't know who actually does it, but like it gets done, so that's good. And like what I'm kind of proposing is, having this be done via pull requests in GitHub. And yeah, that's what this looks like in Terraform. If you can see it, maybe trust me, it hopefully makes sense. And now what happens when you submit a pull request? So the thing on the left here, this is Terraform telling us what it's going to do if you merge that pull request. Basically what it's saying is, I'm not going to mess with the existing stuff. I'm only going to add this one new record that you asked me to add. And so this kind of gives reviewers like a way to look at this and see like, yeah, this is what the person meant to do. This is good. And then when it actually gets merged and approved and like does the thing, here it is showing you that it's doing what it said it's doing. You know, it's not messing with the existing stuff, and it's just adding the new records. And if you look really closely and have better eyes than me, you'll see that it successfully created the record. And both of these steps happen in like under a minute. In both cases, it's like pretty quick, works pretty well. I really don't know if I can successfully demo the things that I want to show with the setup, which is totally my fault. But like, trust me, it works very well. I can maybe I can show you a previous one. So this is like a sample repository I made for the jamesouten.life domain. And I can maybe show you, I think this is going to be records. One of the big pieces here is that like with anything, there's like existing configuration. So I wrote a little bit of Python that's over in here somewhere, trust me, that generated this based on what's actually in name.com. And you can see there's kind of a pattern to these record names. And then I also added other stuff and made changes to stuff after that as well. And like, yeah, it works. It does the thing. Yeah. And this is maybe pull requests. That's actions. Let's see. Okay. This is one that there might be a slide of this, like it automatically comments on this saying it all worked. And the change, what it actually looks like is, you know, on this domain name, add, can't even really see this, add this host name with this record type and point it to wiki.mesh.nyc. Mesh.net, so yeah, it's relatively easy to add new stuff, do things. Yeah, and this is publicly available. You can all go look at this. I'll drop the slides so that you guys can actually see it. Sorry, it's not as viewable right now. So next steps here, like if this sounds like an okay thing to do and people think that there's consensus about this is not horrible, like maybe we could do this. And rollout, what it would look like is adding, you know, the proper credentials to the GitHub repository. There's like that Python script I wrote to transfer the state so that Terraform knows about it. And then I actually also opened a merge request in the actual like mesh DNS repository to like do this. So yeah, and we could merge that, and then you know we can maybe start using it for all kinds of changes. And one of those changes would happen to be like making this bottom one not just one server. One of the requirements for making this more than one record is adding a record, and so I would also, you know, be totally fine with going through this process, testing out this process, using this process to also add another DNS server so that that would hopefully make a DNS outage less likely, while also making all of that way more transparent, in my opinion. So yeah, that's all I got. I guess if you have any feedback on this or suggestions, feel free to let me know now or later. If you have any like concerns or whatever. Yeah. Any, I am kind of curious, like any feedback, questions? Thank you.
Hello. Yeah, so I think this is a great idea because I think that the current setup, like for the mesh zone, is like great. It's very easy to just make a PR and all that stuff. It is so cool that we are considering adding like nycmesh.net to that. Like that's huge. I think it'll make it a lot easier to set up sort of more top level like projects and stuff. I know that I've tried to like have nycmesh.net like stuff added before. When I was like a noob here, it was like really confusing to be like, hey, who do I have to talk to make this happen? But now it's like, okay, cool, I can just open a PR here. So that's very nice. I guess I'm curious, like, why exactly did you choose Terraform and not like something else? I think Terraform's pretty sweet. I'm just like curious if you have any like specific strong opinions about that.
Yeah, so basically that means that I have to write less code, even though, to be totally honest with you, I already wrote the Python to do 90% of this, like, and then I realized like, oh, why am I not using Terraform? Why did I not search and see that there's already a thing to do the thing that I want to do after spending an hour on it, 2 hours, 3 hours, whatever. So yeah, but I think, yeah, time savings, maintainability, and like also like on some level, I'm not sure that I want to write the code that like really is responsible for this, like writing the script to generate a thing for the human to look at and review. Yeah, but like writing the code that could accidentally break DNS, no way. I do not want to do that. So that's why.
Okay, makes sense.
Don't
Thanks.
reinvent the wheel.
Lightning, do you have a question?
Yeah. Mine's pretty quick, and I'll pass this to Piotr. This is the first time that I've heard of the name.com thing. It makes sense to me now that we have something that is doing DNS for our nycmesh.net domain. Do you have a list of what's running on that? Because I don't.
So I'm going to post the slides to this later. And as some of you may know, I have been looking into that kind of thing separately, found some interesting stuff. But in the appendix, I would encourage you to take a look at DNS Dumpster. It's a funny name, but like that is one way to like try to learn about that. Honestly, it's what I used to like do a lot of this like figuring out of what is going on. So yeah, check out DNS Dumpster.
That'll do a DNS search and be like, these are all the things that are on this domain.
It won't tell you absolutely everything, but it'll tell you enough things that
you can kind of figure it out.
Yeah.
Sweet.
Okay, so I've got a couple of questions. Would part of your setup, would it include adding A records for all of the existing omnis? Or that's something that you don't want to do? Did you program this in your script?
So you're talking about like RDNS for all, like,
within
the entire
mesh
IP blocks?
domain, that mesh, so to have like a actual domain name for all the omnis on the network.
If you want to do that, you'd end up having to need to add a lot of DNS entries, right? And you'd probably want to do it in a structured way. If you manage it in Terraform, I think it would be significantly easier to do that using loops, as opposed to having to like, I don't know if I showed it here, but like if you have to go and like click an ad, it's never going to happen. Or at least for me, I would never do that, because that'd be horrible. And like, even if I tried, I would mess up a handful of them.
All right,
So
let's
like,
say that's
I
not
think
gonna
that,
happen.
I think if you wanted a system to do that, this could possibly be the thing that you were looking for. Though, to be clear, I'm not committing to doing that on day one, but if you want to work on it together, we could talk about that.
But I have a follow-up question on this one. Okay, let's say that's not going to happen. So how are you going to prevent spoofing that name by someone else?
Yeah, so I think that's like unauthorized access to like the credentials that would be used to roll this out and stuff. Like if I can break into name.com, then, you know, I could do bad stuff with DNS. So like right now, I'm not aware of any kind of transparency aside from like DNS dumpster. For like actually having accountability checks and balances on like what records exist. So right now I don't know how to answer that, but perhaps if we had a system like this where the records that are approved and all agreed on, if we have that in structured format, perhaps we could enhance this to every day, every week, go check, does the actual configuration match the configuration that we expect? If yes, great. If no, send a message in Slack or like, let us know. So again, that's not a thing that I am currently committing to doing, but also like if you want to do that, I would also be interested in working with you. And I think that this kind of a system would make that a lot easier. So yeah, if you want to do that, let's do it.
Fair enough. And last one, would your system allow adding NS record?
Yes.
Meaning something that I'm committing to this name and whatever is follow that name and manage this by myself by adding NS record.
Absolutely. And so an NS record is the thing that makes, let's see. An NS record, there's currently one NS record for mesh.nycmesh.net that's pointed at the IP of this server. And so, yeah, you can, if this happens, we'll see that record exists in the Terraform. We'll be able to see that it exists. If we want to add another one, we can do that. You know, we have to have a server to point it to, and yeah,
Right.
we have to do that work. But like,
I understand
yeah,
the concept.
yeah. But if you want to do more zones, if you want to do other stuff, like client, what is it, IPv4.nycmesh.net, that's a thing you can do.
All right, fair enough. Thank you.
And it would just be like more transparent if it's in text. Sorry for going over.
Pizza's here, by the way.
Oh, that's hard to compete with.
I'm not saying that I know what these things are, but can't you use stuff like DNSSEC and RPKI and ROAs?
Whoa. Yeah, dude. Hey, we should talk later. Because, hey, it turns out if you want to reliably roll out DNSSEC, which is a thing that I think wouldn't be bad, right? You'd probably first want to start with a centrally managed thing that can be transparent and be maintainable. That you want to manage DNS in a way like that. So yeah, and if you want to do DNSSEC, let's talk later because that would be really cool. And I think that would be a good thing for the mesh. Dang, I'm not the only security person here.
Brian, do you have a question?
No, I think we've run out of time and the Peter's here, so.
Sorry.
So we can break up the discussion groups, and I'm happy to take on any non-technical discussions if you people want to speak to me, and there's obviously other people